Probability can be super complex if you don't frame it correctly. One of the keys to looking at probability problems, particularly conditional probability and independent probability problems, is breaking each part up into its own entity. And a lot of times this really clarifies the problem. So let's take a look at this XYZ probability problem. Xavier, Yvonne, and Zelda, and they're solving problems and yada, yada, yada. So we're given the 3 probabilities for correct answers, and we're being asked, what's the probability of X right, that is X solving it, Y solving it, and Z not solving it? So the first thing we can look at is say, well, what's the probability of Zelda not solving it? And it's just going to be the flip, that is the other side of 5/8 to bring us up to 1. If she solves it 5 out of 8 times, she's not going to solve it the other 3 out of 8 times. So we're dealing with 1/4, 1/2, and 3/8. The math here is straightforward. Multiply them together. But that might not be readily apparent, or at the very least, just plugging it into that formula can get you into trouble. So here's where owning it conceptually and mapping it out with a visualization really helps you take command of this problem. Since each probability is independent of the others, we can look at them independently. What's the probability of Xavier getting this correct? 1 out of 4 times. So we can say in general, for every 4 attempts, he gets it correct once, or 25%. If, and only if, Xavier gets it correct, can we move on to the next part, Yvonne. Xavier gets it correct 1 out of 4 times. Then, what are the chances that Yvonne gets it correct? 1 out of 2. So to have Xavier get it correct, and then Yvonne get it correct, it's going to be 1 out of 8 times, 1/4 times 1/2. It's not that we can't look at Yvonne when Xavier gets it incorrect, it's that it doesn't matter. So from a framing perspective, this is all about only looking at the probability for the outcome that we want and ignoring the rest. Xavier 1 out of 4, Yvonne 1 out of 2 gets us to 1 out of 8. Then, and only then, what are the chances that Zelda gets it incorrect? 1 out of 8 trials brings us to X and Y are correct. Then we multiply by the 3/8 that Zelda gets it incorrect. That gets us to 3/64. 3 out of every 64 attempts will end in correct, correct, incorrect. This is one of those problems that you may have to go through a few times, but once you attach the explanation to it, you can't mess up the math. Thanks for watching, guys. More probability and other cool problems below, and we'll see you next time.